So in order to do this question, we're going to need to look at this situation in three different viewpoints. Okay? What we're going to look at is if we were looking down from the top on the whole situation. If we were looking down on the top from the whole situation, there's going to be a point here. I'm going to call this the tower. Okay? I'm not actually going to draw a tower because I'm looking straight down on it. We know that David is due north of the tower, so right here is David. I'm going to sorry. And that Brenda is at a bearing of 175 degrees. Now when we do a bearing, if we draw north, south, east, and west, a bearing always starts at north and goes in a clockwise direction. So if you went in a clockwise direction from north 175 degrees, she would be down there. So the situation makes from the tower to David to Brenda, and this is what we're trying to solve, how far apart they are. It makes a triangle. That triangle that we're given has only one piece of information so far. We know that this angle right in here is 175 degrees. But we also know in order to solve anything with a triangle, we need three pieces of information, and one of those pieces of information has to be a side. So this triangle, the way that it's drawn right now, doesn't have enough information. But now if we take a look back at other information that we're given, we know that David is due north of the tower, and if I actually draw the tower here and draw David down over here, we know that his angle of elevation to the top of the tower is 70 degrees. This is not drawn to scale, but that would make a right-angled triangle. Okay? And we know the tower is 35 meters tall. So this is just the situation from a side view, looking at the tower and looking at where David is and his angle of elevation. We can do the same thing, 35-meter tower, for Brenda. Her angle of elevation is 50 degrees. Again, this would make a right angle there. So these are the three different situations. If you wanted to sort of put all the situations together in one diagram, you could make a three-dimensional diagram. I'll draw that quickly just so you have a sense for what that looks like. Say we have a tower. We've got David due north of that tower, looking up at an angle of 70 degrees. We've got an angle between David and Brenda of 175 degrees. So this is the distance between David and Brenda that we're supposed to find. And then we've also got a 50-degree angle of elevation for Brenda looking up at the tower. When you put them all together, it gets kind of confusing because, you know, this, the way that I've drawn it, looks like a 90-degree there, but it's harder to see that this triangle here also has a 90-degree because of the angle you're looking at it. When you try to put it together as a 3D model, it's harder to see. So instead, what I've done is I said from the top, this first triangle that I have, that's this triangle down here with the red length. And then I've got two side views of these other two.
What numbers on the side on the
That's 35 as well here. Now we're going to color code some important things. Okay? First of all, we're going to color code this length in black. Okay? Can you see using sine, cos, and tan that you could figure out that length? With the angle of 70 degrees, that's the adjacent side. And which side do we know? We know the opposite side. So we could use tan here to find that length. Now the important thing about that length, can you see that this length here is the same as this length on the diagram? From the top view down, this is the distance that David is from the tower. And on our top view, here's our tower, and there's David. So I can figure that out by going tan of 70 degrees equals the opposite side over, I'll call this x. Actually, I used x already. I should use a different letter. Let's call it a. And so a will equal 35 over tan 70. And we can figure that out. While the calculator's getting ready, I'm going to color code this one as well. The distance that Brenda is away from the tower, that purple line, that matches up with this purple line there. Again, we can use tan. Tan of 50 degrees. I'm going to call this B. 35 over B. So B will equal 35 over tan 50. So I'm going to go to my calculator. I'm going to figure out the first one, which was 35 divided by tan 70. That's 12.738. I'm going to store that as A because that's the letter that I chose for it. So I'll remember later that I've got 12.738 stored as A. And if I do 35 divided by tan of 50, 29.36, I can store that one as B. So I've got 12.7 and 29.4. And we can label those on here. So now I know this length is 29.4 and this length is 12.7. Now when we look at the first triangle that we drew, we now have three pieces of information on that triangle. We have two sides, the 12.7 and the 29.4, and we know that the angle was 175 degrees from the berry. So now we have enough information to solve for everything on that triangle. The question we have, what kind of triangle is it? Can I use sine, cosine, tan, and a squared plus b squared equals c squared? No, because it's not a right angle triangle. Can I use the sine law? Do I have an angle on the opposite side? I've got the angle, but I don't know the opposite side. And the other two angles I don't know, so I can't use the sine law. So I'm going to need to use the cosine law. So to solve for x, 29.4 squared plus 12.7 squared minus 2 times 29.4 times 12.7 cos of 175 degrees. Again, the thing that we notice about the cos law is whatever angle we're using, the opposite side is what's listed. Now when I go to type this into my calculator, because if I use these values that are right here, they're all rounded. So my answer is going to be off a little bit. But since I stored these values as A and B, I can go to my calculator and I can write a squared plus b squared minus 2ab cos 175. Since I've already stored it as a and b, I'm basically writing the formula in just as it looks like on our formula sheet. 2ab cos c. So we get 1770. That's what x squared is going to equal. And on my calculator, I can go second square root of my answer and get x is 42.0. What does it say? To the nearest? Does it tell us? to the nearest meter, so 42 perfect. 42 meters. So the questions you can do for this one, what page are we on? 496. Numbers 9 and 12.